Today's topic in graphs it's about breadth first search algorithm. So first step is introduction. In introduction, we are going to consider what's breadth first search algorithms, and I'm going to show some illustrations with examples. Breadth first search is a graph traversal algorithm that starts traversing the graph from the root node and explores all the neighboring nodes. Then it selects the nearest node and explores all the unexplored nodes. And when we're using BFS, all the nodes they are considered like root node. Time complexity of BFS it's OV plus E. V it's a vertices and the E edges. And then very useful and important thing in BFS that in the most situations BFS use for finding the short paths on unweighted graphs. So let's consider BFS 3. And BFS starts at some arbitrary node of a graph and explores the neighbor nodes first before moving to the next level neighbors. Let's consider that 1 is our source node. So we visit 1, add to our new graph, and I go to neighbors. It's a 2 and 3, we add them, and go next level neighbors. So next level neighbors for 2 is 4 and 5, and 3, and for 3 is 5, 8, 7. And here connection between 2 and 3, but we already visit these nodes, so we didn't add them, didn't repeat them. So okay, we add for our graph, and we visit the last one, it's 6. And here we have the short path of this graph. So add non-tree edges. As I said before, we have some connections between nodes which we don't consider in new graph because they already was visited. Next steps it's about code, how it looks like, and I'm going to show some examples with Java. Pseudocode of BFS. Here we have functions with values g and s. G is a graph and the s is a source node. And the main thing in BFS in the most situations it use Q. Q is a data structure with logic like FIFO. FIFO is first in and the first out. For example, we can say when we are waiting and say in queue for a restaurant, first client go into and go out. So next clients will do same algorithm. Q has function in queue for add values. So here we add source node and the mark that is set is S. Our source node is visited. And then a while loop. In while loop we have Q is not empty. So it will go while Q is not empty, and we are going to remove top value in Q, and then check all neighbors for this node. If they are not visited, so we add neighbors and mark that this neighbors was visited. But if they are already visited before for loop, so we don't consider it. Okay, I'm going to show how it look like in Java. It's IntelliJ. Here I have graph. It's my class with values v linked list q. V its number of nodes. Here linked list because I'm going to use like adjacency list. It's very useful, comfortable for this algorithm. And as I said before, q it's very important. Okay, here I think we are check create graph and add new edges between my vertices. And the main part of this code here, it's a BFS function with a Boolean massive. Boolean massive for check if this node was visited or not, if visited true, if not false. So first node is visited, so we add, and while queue is not empty, we are going to remove first one, and for all neighbors of this node, for get all neighbors, we use get function, and in if we check if they are visited or not. If not, we add and mark as visited with true value. The main function, I create graph and add insert new values for my graph. Here I call my graph and put value 1. It's my source node. So let's run it. And then my output will be the breadth first traversal of the graph. It says follows: 1, 2, 3, 4, 5, 7, 8, 6. It's a short path for my graph. Now I'm going to show it through illustration. Here in this illustration, values are the same like in this code. One, it was our source node we visit and remove from queue. Then visit neighbors of 1, 2, and 3, and go to our next value. It's 2. Remove because it was visited. Then check neighbors of 2, 4, and 5 visited. Add them. And we are going to do same algorithm for all nodes in this graph. So if we are 4, 5, 7, 8, and in the beginning was 1, 2, 3, and the last value is 6. The output is the same like here because graph is the same. Okay, the next step about examples. BFS is really useful and we can use it for applications in real life. For example, crawlers in search engines. Okay, BFS is one of the main algorithms used for indexing web pages. We can follow all the links associated with the page, with the source page. It's very useful. The next one is GPS. In many situations, we use GPS for find the shortest way between one place to another place. So BFS, we can use here this algorithm. Find the shortest path in the minimum spanning tree. I think it's. I think we consider it in our code, and it is clear. Broadcasting algorithm is used to communicate broadcasted packets across all the nodes in the network, and a peer-to-peer networking. So we use this for find all the neighboring nodes in a peer-to-peer network. And here simple example. Let's consider that you are in San Francisco and you are in Twin Peaks. You want to go to Golden Gate Bridge, but here